from now until Thanksgiving, we're going to work on proving triangles congruent. Okay? Now, yes, if all three sides are congruent and all three angles are congruent, right, then our triangles are congruent. But I'm going to teach you 5 shortcuts, okay? We don't have to have all 6 parts congruent to all 6 parts, okay? Ethan. Computer. Okay. So, our first shortcut is SSS. What do you think that stands for? Side, side, side. So, if 3 sides of one triangle are congruent to 3 sides of another triangle, then our triangles are congruent to each other. Okay. I'm going to try really hard to give you some abbreviations so you don't have to spell all the words out. Okay. Okay, so it does not matter if we don't know anything about the angles. If we have all 3 sides marked congruent to all 3 sides of the other, then we can say, hey, these 2 triangles are congruent by side, side, side. Okay, now, our next one is SAS. What do you think that stands for? Okay, now, it is important that the angle is sandwiched in between the 2 sides. So, if 2 sides and the included angle are congruent, are congruent to Okay, I know that it's wordy, but it is important that we say the included angle. The angle being in between the 2 sides matters. We cannot have an angle and then 2 sides because we do not have bad words in math class.
Yeah. Oh.
It cannot be angle side, side.
I still get it. So just think about it. Angle is first and then side, side.
Oh. Hey, don't say that. It's sad.
See Josh's wall up there?
I'm ignoring it. Okay, so here's the deal. I have 2 sides congruent to 2 sides. Go ahead and mark that. The included angle, which would be which one? Okay, the one that both sides create. The angle has to be in between the 2 sides because there are no bad words in math. There is no SSA shortcut. I spelled it backwards. I can't spell it the other way.
Why not?
Got it.
Okay. All right, and then our third shortcut today. HL. Ooh. HL.
Height and length.
Homelander.
Not hypothesis. Hypotenuse and
And length.
leg. So we're talking about a what kind of triangle? So this is specific to a right triangle. Okay. So if a hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then our two triangles are congruent. Okay, what I want you to kind of take away from this, as we're like kind of drawing this all out, we always need 3 pieces of information. 3 sides for the first one, 2 sides and an included angle for the second one. I know that our shortcut is only HL, but our third piece of information is that it has to be a right triangle. So I have 2 right triangles. Ooh, that is bad, Carrie. Okay. Our hypotenuses are congruent and either leg. Okay. We have hypotenuse leg because there's no bad words in math. This is the only time we can have 2 sides and an angle. That's not in between. Do you see what I'm saying here? Okay. All right. So. Yep. What do you need? What did you say?
Nothing. You didn't get it. You didn't get the joke.
It's gonna be really sad when we have to turn the page. Okay. So, question.
Can I get a picture real quick?
Are these 2 triangles congruent?
Yes.
Okay. So, I'm going to say that triangle QTY is congruent to triangle C. If it's QTY, CPK. And how do we know that these 2 are congruent? Ah, give me some sass. Side, angle, side. Side, angle, side. Side, angle, side.
Hey. Watch yourself.
Okay.
When the ice gets too thin, you fall.
Now, I only see 2 sides marked.
They share.
Oh my goodness. Would AC be congruent to itself?
Yeah.
Okay, what do we call that? What property? That's called the reflexive property when we say that AC is congruent to itself, right?
What are map tests?
What does that have to do?
Okay.
I don't want to know either.
So we can say that triangle ABC is congruent to triangle A, B, C, C, D, A by side, side, side.
So when we're doing the proofs, do we only have to put like SSS or like
All right.
first?
Okay, look at letter C.
Can't do that.
Why not, Logan?
Because you can't have bad words.
Okay, so what's the real problem?
It's not in between like the two congruent sides.
Okay, our angle is not included in between our congruent sides. So these two triangles are not congruent.
It's not a right triangle, so the
So we have side, side, angle. That's not the order we can have.
Oh.
Oh, yep. Okay. I really like letter D.
I don't.
Okay. I want you to think about parallel lines in a transversal. When we have alternate interior angles, kind of makes a Z. You see that? Okay. So we have parallel lines here. Do we have that Z happening?
It happens twice.
It does, but we can mark that D and E are congruent because they're alternate interior angles, which means we can show that these two are congruent by using some SAS. Side angle side. So we can say that triangle ADJ is congruent to triangle AEM by side angle side. What? Did somebody ask why it's side angle side? Okay, so do you see how I have these two sides marked as congruent? And our angle is in between? So sometimes we have to mark a side or an angle. So since we had parallel lines, I had to mark my angles congruent. Okay. Okay. How about you see what you can come up with for E and F?
Miss Holman, do we have to twist the spinny thing back? Why? What's fun to use?
I bet it is. What if I just slam it?
Okay, who wants some pieces now?
Oh yeah, cause a disruption. Thanks, Josh.
What are the? How do we label it if there's no? Oh yeah, we write it out if there's no.
Oh shoot. That's right.
It's A, B, C. Is
How about we label it A, B, C, D like that? Tissues are up here or back there. All right, here we go. Are the two triangles in E congruent? Okay, EF is congruent to itself. So we can say that CEF is congruent to triangle DEF by
SSS.
side, side, side. Okay. Now, I forgot that I didn't label. Will you label F like this, A, B, C, D? Okay. So we can mark AB as reflexive. What theorem are we going to have to use? Okay, this one is hypotenuse leg. We have a right triangle, the hypotenuses and leg congruent. So triangle ABC is congruent to triangle CDA by hypotenuse leg. Okay. Now, what I'm going to ask you to do is I'm going to ask you to write a 2-column proof showing me 2 triangles are congruent. I will never give you a proof you cannot complete. That would be just pure evil. I would not do that. Okay? And whatever you think of me, I am not evil. Okay? Okay? Now, things that you might need to look for to help you with congruent sides that aren't given to us. You might get a midpoint, and you can use definition of a midpoint to write 2 segments are congruent. A lot of times, we've already seen it 3 times. You will have to use the reflexive property where a side is congruent to itself. Okay? Things to look out for angles. Yeah.
Oh, will we have to do proofs in YouTube?
No. Honestly, you will be done with proofs after your final in December.
Oh my gosh, thank goodness.
Okay. Yeah. And honestly, of all the proofs you've had to do, in my opinion, these are the most straightforward because you have a checklist, okay? You need so many sides and angles congruent, and then you're going to know what you need in your proof before you write it down, okay? Because we're going to look at the picture, we're going to make decisions, okay? For angles, if they're not given as congruent, we have vertical angles. We can use parallel lines with either alternate interior, alternate exterior corresponding, or we can use the definition of a bisector, okay? So let's look at this first proof right here. Okay, let's go ahead and write down our given and mark our diagram. So it is given to us that PQ is congruent to ST, QR is congruent to RT, and I can't fit it all in one. RT is the midpoint of PS.
It's just hard.
What? Sorry. Yes, Ethan. Excuse me. Our last step, yes, we can put SSS. Okay? Okay, so let's mark what we have. PQ is congruent to ST. That already is one set of sides congruent. Okay? We also know that QR is congruent to RT. Okay? There's a second set of sides congruent. Okay? If R is the midpoint to PS, what can we use that for? Jack? Yeah. Okay. If we have something in the given that isn't a set of sides or angles, we need to use it. So since I have R as the midpoint, I am going to use the definition of midpoint to write that PR is congruent to RS. I'm going to mark it in my diagram. Okay, so I have the 3 pieces of information that I need. I have 3 different statements about 3 different congruent sets of sides. So we can now conclude that triangle PQR is congruent to triangle STR by side, side, side. Done.
I have one question.
I have one answer.
On these, does it matter like what order I put the triangle in?
So, on example 1, it matters that the corresponding pieces match up, but it doesn't matter the order. Here, the order matters because I need the proof to be exactly what we land with here. Okay? So you'll notice, like when I make any of my answer keys in any of my notes, I'm going to highlight the 3 pieces of information to help you visualize like the sides or the angles that we need in our statement. Okay? We always need the 3 pieces of information. This one was a side, side, side. Okay? Did you have a question? Oh, lunch question. Got it. Okay. In example 3, go ahead and write in the given and mark it on your diagram. If you don't mark your diagram, I'm disappointed.
Cabbage.
I'm disappointed in you.
I'm thoroughly disappointed.
Let me get this twisted one back.
So AC and AD, ooh, that's a set of sides. CB and BD, ooh, that's a set of sides.
Wait, do you have to say that in your thing?
Wait a minute,
Or for AB, would you have to
AB
do
is
this?
congruent to AB.
Then do the reflexive properties so that you
AB
can
is
say that
congruent
it's.
to AB.
Okay, so Aaron had a question. Aaron's brain was already going towards the end. Okay, my last step is going to be what theorem? Side, side, side. But Aaron said we only have 2 sides, so we have to put our third set of side as AB is congruent to itself because of the reflexive property. Okay, now we have 3 sides congruent to 3 sides, so we can conclude that triangle ABC is congruent to triangle ABD because of side, side, side. Do you see why I said these proofs are a little bit more straightforward than our other ones? Like we have a clear goal and really pretty clear ways to get there. Okay? Feeling good, feeling good. Okay, let's go to example 4. We haven't done any side angle side ones, so I just want to...
Oh yeah, we gotta learn them all.
Doing all of them?
Oh my gosh. Bunch of whiners over here. Okay. AC is congruent to BC. Uh-oh, that's not what it's supposed to say. Typo, typo, typo. Will you change this to B? AB. Because that makes more sense if AB and BC are congruent. Sorry.
I think the original one.
Okay. And BD bisects angle ABC. Okay. Okay. So I only have 1 piece out of the 3. So we're going to need to write out 2 different pieces. Okay? Let's use our given. If BD bisects ABC, what kind of statement can we make? Ethan?
Segment AD is congruent to segment BD.
So if a segment is bisecting an angle,
Oh wait, that
The angle. Oh, no, 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 no. If BD is bisecting our angle ABC, then it is giving us two congruent angles. Angle ABD is congruent to angle CBD because of the definition of bisects. Bisecting an angle creates two congruent angles. Okay, so there's a side, there's an angle.
Sassy triangle.
Oh, it's a sassy triangle. How do I get my second side?
BD is congruent to itself.
Okay,
Crazy theory, guys.
so we can use the reflexive property on DB or BD, I don't care. You decide. But now, so I'm going to mark it so I can see I have two sides and an included angle. So I have ABD is congruent to triangle CBD by side angle side.
Can we do side, side, side by saying that D is the midpoint of A?
Did it tell us that?
Well, no, but if
Did it tell us that?
No,
Can we assume it?
I guess not.
Okay, so here's something that sometimes is hard. I could hear people say, ooh, it's a right triangle. Does it say that that's a right angle? Then we can't assume it. Yes, it looks like D is the midpoint, but does it say it? Can we assume it? No. We can only use what's given to us. Okay? So let's do example 5. I think you want to do example 5 because of the parallel lines. Okay? It was definitely the printer's fault and not mine. This C is really a G. Yeah. That C, change it to a G. Bathroom? It's 22 and we got it at 30. Are you okay with that? Yeah. Okay, make this. Okay, so high is congruent to GJ and high is parallel to GJ. Write it in your given and mark it.
Wait, what does that mean?
Those arrows mean parallel. Okay. So I have 2 pieces of given information. Only one of them gives me a piece. Which means we need to use the other one to get us a piece. So what can I find with parallel lines? Congruent angles or sides?
Angle.
Oh yeah, angles. No, it just needs to be on HI and GJ and going the same way. So do you see a Z?
Yeah, I do. Yeah.
Okay, so I know that these 2 angles right here are congruent. Angle IHJ is congruent to angle GJH because of our alternate interior angles theorem. What? Okay, that gives us 2 pieces. How do I get the third?
HJ is equal to H.
There is no such thing as a bisector here. Ah!
The buddy attack.
That was funny. All right, so the reflexive property. Sorry.
Well, I put ALT.
There, does that look better? So now we can say that these two triangles are congruent by SAS.